Hey, and welcome back to Algebra 2. All right, we're going to continue our conversation with exponential and logarithms. And what we're going to do today is work on finding inverses of exponential functions and inverses of logarithmic functions. And to do that, we're just really going to rely on some of the things that we already know about solving and finding inverses. And to get you thinking about that, what I'd like you to do is find the inverse of that cubic function there in our opener. So take a couple minutes to work that problem. When you're finished, check it through the fully worked notes online or by turning the video back on. All right, so let's go ahead and take a look at the work for finding an inverse. So if we talk about finding inverses, we're going to use one of the key pieces of information we know is that the domain and the range switch. So when we look at our function, we have y equals 3 times the quantity x plus 2 cubed minus 8. So we're going to switch our domain and range. We're going to switch our x and y so that I get x equals 3 times the quantity y plus 2 cubed minus 8. And now what we want to do once we've switched our domain and range is we want to solve for this y right here. And once we've done so, we'll have our inverse function. So the first thing I'm going to do is add 8 to both sides. So x plus 8 equals 3 times the quantity y plus 2 cubed. Then I'm going to divide both sides by 3. So I get x plus 8 divided by 3 equals y plus 2 cubed. Now here's really the vital piece here is that in order to get to this y, I have to undo, right? I have to do the inverse operation right here of something cubed, right? And the inverse to cubing something is to take the cube root of both sides. So I end up with the cube root of x plus 8 divided by 3 equals y plus 2. And then my final step to solve for this y here is to subtract 2 from both sides. And once I've done that, this is the inverse function. All right, and then that's what we have. Now, the great news about what we're going to do today is it's going to follow this exact format here. So we want to switch our x and y's, right? We want to switch that domain and that range, and then we want to solve for where that new y is. The only difference today would be as we do this, we have to remember what our inverse operations is, right, for each particular function. So what's my inverse for an exponential? It's a logarithm. What's my inverse for a logarithm? It's an exponent. All right, so in much the same way that the square and the square root, cube root, multiplication, division are inverses of each other. So if we flip back here to the note sheet, all right, we're going to, all right, find some inverses here, and we're going to start by finding inverses of our exponential functions first, all right? And we're also going to do a little bit of domain and range, all right, to help us with that as well. And so remember that the inverse of any exponential with base b is log base b. So eventually, in the same way that we had to take that cube root a second ago, we're going to have to take a log of both sides of our equation to find our inverse. All right, so let's start by looking at our exponential function here. Now, we're going to start with our domain and our range here. And then what we know based on our domain and our range, all right, is that we know they're going to switch. And so this also provides us a checkpoint once we do have our inverse function at the end. Now, what we talked about is the domain for every exponential is going to be all real numbers. All right. Now, our range, we said for every exponential, is going to be from our horizontal asymptote and then above. So when I look here, this plus 5, we said is going to represent our horizontal asymptote. So our range is going to be 5, all right, to infinity. And so there's our range. Now, here's what we already know. So we know we're going to look for our inverse function. We already know the domain and the range, all right, switch. So our function at the end should have a domain 5 to infinity if we did things correctly, and it should have a range of all real numbers. So we already know this is to be true, and then it can provide us a little self-check at the end. All right, so now let's go back to this function here. And I'm going to just go ahead and put our y in here. So y equals, all right, 2 to the x minus 3, and then plus 5. And then what we said we want to do first is switch our x and our y. So now we're going to have x equals, all right, 2 to the power of y minus 3, and then plus 5 here. All right, and then now what we want to do is we want to solve for this y in much of the same fashion that we did on the opener. So I'm going to subtract 5 from both sides here. All right, subtract 5, subtract 5. All right, and I'm going to rewrite it right here. So we'd have x minus 5 equals 2 to the y minus 3. All right, so now here's where that inverse operation is. I have to get to this y. So to do that, I have to take the inverse of this exponential. Well, since it's base 2, the inverse of that would be log base 2. So I'm going to take the log base 2 of both sides of the equation. And so remember, I can do anything I want to an equation. I can perform any operation as long as I perform that same operation on both sides. So I'm going to take log base 2 of the left side, and I'm going to take log base 2 of the right side. And we get to this. Now, the left side, there's nothing we can really simplify for that. That's kind of like the cube root of x minus 5, the log base 2 of x minus 5. So I'm going to bring that down. So log base 2 of x minus 5. Now, I'm going to take the long route on this problem so you kind of see exactly what's happening here. And so here's what happens. If we look, I have a power here. So we're really going to use that power property that we've talked about, and I'm going to take that y minus 3 and I'm going to move it out in front of our logarithm. And so here's what happens. And so I'm going to move that y minus 3 out front, and I'm left with log base 2 of 2. Now, what do we know about log base 2 of 2? That result is 1. They have undone each other in the same way that the square root of x and x squared undoes each other and leaves us with just that 1 right every time. So this really what happens every time, but what you will see is that most problems they won't show this step right here. They'll go right to this step. They'll show log base 2 of x minus 5 equals y minus 3. So they'll show this log base 2 of both sides, and then they'll jump from this line to this line because, all right, intuitively what's happening here is you're doing that power property, moving it out front. We're going to have log base 2 of 2, which is always going to be 1. So you can include this step if you want, or you can go right from this step to this step. All right, either way is fine. And then our last step to solve for y here is we have to just add 3 to both sides. Now notice I cannot add 3 to this negative 8. That's inside. I'm taking the log of all that. So that's kind of like being inside of a radical, inside of an operator. So I would write this as log base 2 of x, all right? And I think I changed that to an 8, or it looks like an 8, but it should be a minus 5, like so, and then plus 3. And that is our inverse function. All right, and so now when we look at this, we know that a logarithm is based on its vertical asymptote. Well, where's the vertical asymptote for this? It's going to be at 5, and then it's going to be to the right. So that does match what we have right here, and we know that the range of every logarithm is going to be all real numbers. All right, so let's do another one together here. So let's take a look at, try to extend the page a little bit here, at number 3 here, and we have base 10. So let's jump into, all right, writing this with y equals out front. All right, so y equals 10 to the x plus 4 minus 1. All right, and once again, I'm going to go ahead and, I should start with my domain. We know that the domain for every exponential is, all right, all real numbers. And then our range is going to start at a horizontal asymptote, which in this case is -1. All right, so our range is going to be -1, all right, to infinity. All right, so now let's flip our domain and our range. So we know it. We're going to have x equals 10 to the y plus 4 minus 1. All right, so now I'm going to start solving for this y. So I'm going to add 1 to both sides. All right, so I get x plus 1 equals 10 y to the 4th. All right. And now, once again, this is where we have to do the inverse operation. So I'm going to have to take log base 10 of both sides. Now, remember, log base 10 is just log. So I'm just going to take the log of both sides here. So x plus 1, all right, equals the log of 10y plus 4. Now, once again, all right, and I'm just going to kind of bring this up here so we can just see it a little bit better. All right, that left side is going to stay log of x plus 1. All right. And just like before, I would take that y plus 4 out front, and I'd have log of 10, which is 1. So that's going to leave me just y plus 4. And we can just jump right to this step. And then my final step here would be to subtract 4 from both sides, all right? So I get log, all right, of x plus 1. And once again, all right, I can't combine anything with this because I'm already taking the log of everything inside, so I can't combine any like terms there. And once again, my eraser is going crazy on me. Oh, goodness. Which was not what I wanted to do. But luckily, I can pause and correct, all right, without too much worry now. So, and then that is our inverse function, right? And then once again, we can see that we know that the domain for a logarithm is going to start at the vertical asymptote, which in this case is at -1. All right, so we know that's going to be -1 to infinity. All right, and we know the range, all right, for every logarithm is all real numbers. All right, so there you go. All right, so here's what I would like you to do. All right, is I would like you to do 4 and 5, and then we'll see how you do with that. Now, one hint, remember that we have base e here. All right, so the logarithm for that would be the natural log, or ln. All right, so try 4 and 5. Turn the video back on, check your work, or check it on the fully worked answer key. All right, so let's take a look at number 4 here. And I just wrote everything out here. Okay, so let's start with our domain. We know the domain for every logarithm is all real numbers. And then our range in this case would be 5 to infinity. All right, so I flip our x and y. So I get x equals 2 e to the y minus 3 plus 5. So our first step would be to subtract 5 from both sides. Now, notice this problem and number 5 had an additional step because we have a constant other than 1 in front of our exponential. So to get to that exponential, I have to divide by 2 on both sides. So I get x minus 5 divided by 2 equals e to the y minus 3. And now this is where I have to undo that exponential by taking the log of both sides. And since it's e as my base, I would take the natural log of both sides. That gives me the natural log of x minus 5 divided by 2 equals y minus 3. And then our final step would be to add 3 to both sides. And so my inverse function would be the natural log of x minus 5 divided by 2 plus 3. And once again, you can see that the domain would be from 5 to infinity, all right, which would match our range here. And we know the range of every logarithm is all real numbers. All right, so let's take a quick peek at number 5. All right, so the range for all exponential functions is all real numbers. All right, we know the range would be from the horizontal asymptote and up, so 9 to infinity. All right, so let's flip our domain and our range. So we'd have x equals 4 times 7 to the power of y plus 5 plus 9. So once again, the first step here is that we're going to subtract 9 from both sides. And then we have to divide by that constant out front of 4. So to isolate our exponential here, we have x minus 9 divided by 4 equals 7 to the y plus 5. Now, once again, we have to do the inverse to base 7, all right, as an exponential, which would be log base 7 of x minus 9 equals log base 7 of 7 to the y plus 5. This is equal to 1. That leaves us y plus 5. Subtract 5 from both sides, and our inverse function is log base 7 of x minus 9 divided by 4, and then minus 5. And then once again, you can see that the domain would be 9 to infinity. The range would be all real numbers. Okay, so that is how we find the inverse of an exponential function. So what we want to do now is we want to look at how do we find the inverse of a, all right, logarithm, okay? And so what we want to do is really, it's the same idea, but now we have to take the inverse of a log. And what we call that is exponentiating when we do that, because we have to take an exponential of both sides. And you'll see what that looks like as we go through the mechanics. But the good news is really the mechanics are mostly the same. All right, so let's look at our domain and our range. Now, when we look at the domain of our logarithm, we know it starts at the vertical asymptote. And our vertical asymptote, because of our horizontal shift, would be to the right 2. So we know our domain would be 2 to infinity. All right, and we know that the range for every logarithm would be all real numbers. So now, once again, we know we're going to flip our domain and range. So we know the domain has to be all real numbers for whatever exponential we get. And it should have a range of 2 to infinity. All right, so if we did the work correctly, that's what we should get. All right, so now just to save a little bit of space, I'm going to go ahead and flip my domain and my range. So I'm going to write this as x equals log base 4 of y minus 2 plus 4. All right, so now, once again, we want to isolate this. So the first thing I'm going to do is subtract 4 from both sides. And I get x minus 4 equals log base 4 of y minus 2. All right, so now we have to undo log base 4. Well, the inverse to log base 4 would be an exponential of base 4. Now, this is what exponentiating means. I'm going to make these two sides of my equation my exponents. All right, so I'm going to make this a base 4 over here, where this is my exponent, and I'm going to make this a base 4 over here, where this is my exponent. Okay, so now what I am left with is an exponential function right here. So I get 4 to the x minus 4 on the left side. Now, once again, 4 to the log 4, those are inverses. That gives me 1. And so those undo each other the same way a square and a square root do, a cube and a cube root do, multiplication, division. All right, and that leaves me on the right side, that leaves me just y minus 2. And now just to solve for that y, I just have to add 2 to both sides, like that. All right, and so I get 4 to the x minus 4 plus 2, and that is my inverse, all right, function. All right, and that is it. All right, now once again, we know the domain for every exponential is all real numbers, and the range starts at the horizontal asymptote, which is 2, and goes up, so that matches. So there's that little bit of self-check at the end. All right, so let's do 2 more together before I have you guys do a little bit more work. All right, so let's look at example 7 here. All right, and notice example 7. All right, maybe. Let's go back up just a little bit here. There, okay, well, a little bit more. All right, so when we look here, right, once again, let's start with our domain and our range. All right, and once again, we know the domain of a logarithm starts at its vertical asymptote. So we have a horizontal shift of left 3, so that means our horizontal asymptote is x equals negative 3. So our domain is going to be from negative 3 to infinity. All right, and then we know the range of every logarithm is all real numbers. Okay, so once again, just to save a little room, I'm going to go ahead and flip my x and my y. So I'm going to have x equals, okay, log of y plus 3, all right, minus 8. Now, once again, I'm going to start by solving for my log. I'm going to add 8 to both sides, plus 8. All right, so I'm left with x plus 8 on the left equals log of y plus 3. Now, once again, in order to undo this log, I have to take an exponential. Now, remember, log is the common log. That means we're base 10. So I need to make a base 10 on both sides. So I'm going to make this base 10 on the left, make this base 10 on the right, and then I'm left with 10 to the power of x plus 8 equals y plus 3. And then my last step here is to subtract 3 from both sides to solve for that y. So now I get 10 to the x plus 8 minus 3, and that is our inverse function. And there it is. And you can see here that the domain, we know for every exponential, is definitely all real numbers, right? And we know that the range starts at the horizontal asymptote, which in this case is negative 3, and it goes up, so that's negative 3 to infinity. All right, so one more, because I want you to do see one with the natural log here, and make sure that you guys feel comfortable with that. So let's do number 8 together. And then once again, starting with our domain, we know it starts at a vertical asymptote, which would be at negative 6, based on our horizontal shift, so we know it's going to be negative 6 to infinity. All right, and then we know the range is all real numbers. Okay, now once again, just to save a little bit of space, I'm going to go ahead and flip my variable. So this is going to be x equals 5, and then I have the natural log of y plus 6 minus 2. Okay, I'm going to add 2 to both sides here. Add 2, add 2. All right, so I get x plus 2 equals 5 natural log of y plus 6. Now, notice that's an additional step because this isn't isolated yet, so I've got to get rid of that 5 by, all right, dividing both sides by 5. So what I'm left with then is x plus 2 divided by 5 equals the natural log of y plus 6. All right, now, once again, I have to undo this natural log, and that would be base e. So I'm going to take base e of both sides, like so. All right, and so I'm going to be left with, I'm just going to write this right here. I'm going to have e. Now notice all of this is my exponent. So x plus 2 divided by 5, all of that, all right, is my exponent. So x plus 2 divided by 5 is the exponent, and that's going to equal to y plus 6. And so my final step to solve for y then is I just need to subtract 6 from both sides, and then this is going to give me my my inverse function here. So once again, e to the x plus 2 divided by 5 minus 6, okay, and that is my inverse function. All right, just like that. All right, and you can see that the domain for every exponential we know is all real numbers, right? All right, and we know that the range starts at the horizontal asymptote, and that horizontal asymptote is our k value, so it's going to go -6 to infinity, which holds with what we talked about with our original function. All right, so what I'd like you to do is 9 and 10 on your own, and then once again, once you're finished with those, either flip the video back on to check your work or check it with the fully worked notes. All right, so for those of you that are sticking around, I have 9 worked out right here, so let's look at 9. All right, so start with our domain. Hopefully you have 5 to infinity, and then you have the range is all real numbers. Now if I flip my variables, I have x equals 7 log base 8 of y minus 5 minus 12. So the first step should be to add 12 to both sides, and then you should divide by 7, and that would isolate our logarithm. So we get x plus 12 divided by 7 equals log base 8 of y minus 5. So the inverse of log base 8 would be base 8. So I'm going to exponentiate both sides with base 8. So that means I get 8 to the power of x plus 12 divided by 7 equals y minus 5. Our final step then would be to add 5 to both sides. So our inverse function would be 8 to the power of x plus 12 divided by 7 plus 5. And then that domain is all real numbers, and then the range is 5 to infinity. All right, one last problem to wrap up today's lesson. All right, so very similar fashion here. All right, so hopefully you have the domain would be 9 to infinity. The range is all real numbers. Okay, so if we flip our domain and our range, x equals 3 log base 11, y minus 9 minus 7. First step, add 7 to both sides, then divide by 3. So we get to x plus 7 equals log base 11 of y minus 9. Now once again, the inverse to log base 11 is base 11. So we're going to exponentiate both sides with base 11. So that gives me 11 equals, or excuse me, 11 to the power of x plus 3 equals, and remember, base 11, log base 11 are inverses. That equals 1. That leaves us that y minus 9. And I simply add 9 to both sides to get my inverse function of 11 to the power of x plus 7 divided by 3 plus 9. And the domain for that function is all real numbers. And the range is 9 to infinity. All right, so that takes care of finding inverses of exponential logarithms, which will come in very handy because our last 2 lessons are solving exponentials and solving logarithms, where you have to perform, you guessed it, an inverse operation in order to solve those types of equations. So take care, my friends. All right, go give the homework a shot. Let us know if you have questions. All right, take care of yourself, take care of each other, and we will talk to you soon.